All right, guys, thank you for coming. Today, I'm not a presenter. Judy, one of our TA, she's now helping, she's gonna go over part of the solution together with you for practice test 1. She took the course before, she did very well, and she knows the subject very well. So don't worry, she's just as good as I am. So today, she's gonna go over with your solution, but if you got any questions during the session, just ask, right? In case if there's any additional information that need to be added, I will get involved as well. We are recording the session, but it's more like a part of the internal TA training process. So we may not make it public after the session. So please just pay attention, right? If you got any questions, just ask Judy. I'm pretty sure she'll be happy to answer. And also, I'm going to make the solution also available tomorrow before the class. All right? If no question. Also, I'm going to take some attendance as well at the end, as I promised, right? Just to give you guys some credits by coming to the session. I'll pause the recording in about 40 or 50 minutes so we can take attendance. Hopefully, you will still stay after, and then we'll restart again. Okay. Judy, go ahead.
Okay. Hello, everyone. Can everyone hear me fine? No? Okay. So I'm just going to walk through the practice test like I would a programming test, just to show you guys kind of the thought process on how to approach a programming test. Okay. So once you've imported the project into your workspace and you've opened it, the very first thing you want to do is open the starter test and get rid of any compilation errors, because we can't actually run the code unless you do that, and you get like a 30% deduction if there's any compilation errors in your code. So for the review session, I'm just going to comment out the test cases so we can go through them one by one. But in an actual test, you would want to go through all of them and make sure everything compiles before you actually approach the solution.
So just to add what Judy just said, if you look at the Lab 1 solution video walkthrough, what I did in the beginning is to show you how to get rid of all the compilation errors first. So you can do that, and then you can pass test by test. That'll be a better strategy. But in the interest of time, Judy just gonna show you for one test case, and then afterwards, she will just show you how to pass test by test.
Okay, so for this first test, I'm going to show you guys two ways to get rid of compilation errors. So you can either do it manually by typing it out. So for example, if you see this registration underline, you can see that it's a different type of object that we haven't created yet. So you need a class for this error. So you click on the model package, and then up here, this little icon says new Java class. You click it, and then you can type the name in. Okay. And then once you've created the class, you want to make sure that it's imported. So if I check here, this import statement the little asterisk just means anything in the model package is imported over. So it saves time. Yeah, so that's how you would do it manually. Eclipse can also get rid of compilation errors for you. So all you have to do is hover over the mistake, and it'll give you options on how you can fix this error. So you want to select the right one. So I'm going to click Create Constructor, Registration, String int. Okay, but to help you while you're coding, you want to rename the attributes that it gives you. So here, the string is the name. The next integer is the number of credits, and the one after that is the number of marks. So I'm going to come back here and change it, just so you don't confuse yourself while you're coding. Okay. So then you can see the errors are gone. However, if you're gonna make Eclipse fix them, you do have to pay attention to what it is generating, because a lot of times it's wrong. So like for example, if I click Create Method, the return type that Eclipse gave is object, but that's not right. You need it to be a string. So you just kind of have to pay attention. It does save you some time, but just make sure you're paying attention to what it's actually generating. Okay. So for this review session, just to save us some time, I'm just going to copy over the constructor and the getters and setters because I think everyone's pretty comfortable with those at this point in the course. So just so we have time to get through everything, I'm going to copy. I'm going to run it. So you have to click the starter file and then run it. Okay, and everything passes. So I'm just going to continue. So this second test case is pretty similar to the first one. The difference here, you can see this new registration. So this is what we call an overloaded method or an overloaded constructor. So it has the same name as this constructor, but the attributes passed are different. So it's a different method. So in here, so this was the original, and then this is the overloaded one. So it's the same thing, just takes different methods. So everyone good so far? No? Okay. Okay, so test case number 3 also has to do with getters and setters, so it should pass on its own. Okay. Okay. Okay, so here we have a new method called getLetterGrade. So I'm gonna hover over it and click create getLetterGrade and type registration. And this method is supposed to return a string. Okay, I'm gonna click save. And then you can see the compilation error is gone. Okay, so what this method does is it takes in the mark of the student that's on the registration and it maps it to some string letter. So what I like to do on a test is copy the explanation over into my class, just so I'm not flipping between the two, and so it's in front of me while I'm coding. I find it easier, but you don't have to. So you can see there's a lot of different cases or conditions associated with the letter grade. So when you see that, you can think if statements. So what you want to do is create a string. I'm going to call it letter grade, and this will store your final result. And then you can start your if statements. So if this dot mark is, the first case here is if the mark is greater than or equal to 90, then the letter grade should equal A+. Okay? And then you just keep going. So else if this dot mark, and then you can see here for like this case, for example, there's two conditions you need to be aware of. So the mark needs to be greater than or equal to 80, but also less than 90. But since you're doing it in an else if statement, if your code manages to get to this point, then you already know that your mark is less than 90 because it does not satisfy this condition. So it moves on. Yeah?
Do we have to declare a variable, or do we just have to return a
You can directly return it, although I know Jackie doesn't really like that. It's better to have it as a string because sometimes if you're not paying attention, you'll get a compilation error because if you put a return in an if, but then don't have any other return statement outside of it or anything in an else, then you get an error. So it's, you can just directly return it on a test if you're trying to save time, that's fine. But it is better to do it this way so you avoid having that error.
Yeah, just to add a little bit more. So I think there's a common kind of suggestion about when you actually have like an accessor, you have only a single return at the end. And before that, you just try to set up the variable that you want to return eventually, so only have a single return. So what Judy said there is actually very practical. If you got, let's say, if return, else if return, but you forgot the else, then the equals is gonna complain. What about when all the conditions are not true? Then you don't have any return statement, like a missing return. So I think it's better to have a single return. Yeah.
Yeah.
When I was doing the same test case, like when I watched Jackie's video, we should like initially I would return whatever the test case tells me. So it says like assert equals and then F. So I initially return F and the test case passes. But when I continue on, the test case never failed. Like they never went back to the same test case, telling me to redo and make a conditional condition.
Yeah.
So when you're for the programming test, if we were to just make the compiler happy and return F, like here's just assert equals F, it passes. So I'm just wondering, like, is there a penalty for that? Because I know we should actually be making it with conditions, but the Eclipse doesn't give like it doesn't fail the testing. That's what I'm just wondering.
So Judy, if you don't mind, let me
Okay.
answer. Yeah.
So-
you answer first. Yeah.
Okay. So what you're describing is what we call hard coding the solution. So yes, your test case passes, but we also add extra grading tests when we're marking your solution. So you might pass that one test case, yeah, but then when we put in different input values, you'll fail the test. So you'll lose out on those marks. So it is better, well, not better, but you're supposed to actually code out the solution and not just focus on passing the test cases.
Also, just to add, also usually the starter tests we give to you guys are not supposed to be complete. For example, let's say in this case here, you can see the description there tells you all the possible letter grades. But in the actual starter test, we only give you one test case. That kind of tells you, of course, you want to pass the starter test at least. At the same time, you also want to program your method in a general way, so you will satisfy the description. Right.
Yeah.
The first question, why don't you use a switch case?
You can use a switch. That's fine too. I think most of us are familiar with if statements, but switches are okay as well. Yeah.
For second question, why use this? Because like the marks itself is not a duplicate. So why even this?
So yes, it will run if you just say mark, but I think it's important to differentiate between like, are you calling the mark for the instance variable itself? So that's what the this does, is you're calling the mark of the object that you just created. Because sometimes, like here, for example, the name of the attribute being passed might be the same as the name of your attribute, like your property in your class. So it will work if you just say mark, but it's just better practice to use the this when you're referring to an attribute in your instance object.
Right? If you recall, back in the lecture, we talked about something called variable shadowing, right? If you look at line number 33, so mark there is a parameter. So line number 34, this mark is referring to the attributes that will break through the shadowing. On the other hand, if you look at what Judy did over there in line number 48, for example, there's no parameter there called mark. So if you don't really have this dot, it's okay. But somehow, if you say this dot mark, it kind of explicitly indicate you're calling the attributes. It might be a better style. Yeah.
Okay. Yeah, so as I was saying, the only condition you need to worry about when you get to this point is that marks are greater than or equal to 80. So, and if they are, then letter grade is A. Okay. So you can kind of see the idea at this point. You would just keep creating else ifs until you get to the last one. It would be an else statement, and then you'd return a letter grade. So to save time, I'm just going to copy it over from the solution.
So on this particular test, right?
Yeah.
Which kind of other tests would you add other than the ones that are already provided for this particular section, because I would say, okay, what if because I don't want to overthink in the exam. What if the mark is actually a negative value? Would you add a test to check that?
I would say usually if we have some explicit assumption about the mark, well, you can kind of look at the problem description there, since we say if the mark is less than 50, so here we just say it will just be considered as F, right?
Yeah.
So here, if we didn't say anything about negative marking or any error handling, you can assume that there's no error handling to be done. So you can just do basically the conditions over there. So in the actual test, if there's any explicit assumption we want you to be aware of, we'll always let you know.
Oh.
Okay.
Okay, so I'm gonna run. Okay. Okay, so this test case, you have a new method called get weighted grade point. It's kind of the same idea as get letter grade, except you're kind of doing the opposite. So in get letter grade, you're going from an integer to a string. Here you're going from a string to an integer, but it's the same. You can use the same if statements and return values, and you should be good. So I'm going to leave that one for you guys, so you can practice and also so we can finish in time. So here you can see you have this compilation error. So this is just telling you that we're starting a new class. So you're creating a new transcript class. Eclipse can also do this for you. So if you hover over it and click create class, it'll give you this, but you need to be careful here because you want to select the correct package. So you want it to be in the model package, not the JUnit. And click finish, and it will make the class for you. Okay. So the rest of the test is on the constructor and the getReport method. GetReport is just like looping through an array and getting the objects in that array. So it's very standard. You guys have done it a bunch in Lab 1, so I'm going to skip over it so we have time for the rest of the test. I'm just gonna get rid of this for now. Okay. Okay. Any questions? No? We're good. Great. Okay, so the next two test cases, 7 and 8, are on add registration methods. So it's pretty standard. You guys have done it a bunch of times at this point. So again, I'm just going to copy it over. And I'm just gonna close this. Okay. So test case 9 is also an add registration method, except the difference here is you're being passed an array of registration. So you're being passed multiple registration objects. So the way to get rid of it, the way to create it would be you'd need a for loop to be able to go through all the registrations you're being passed, and then you want to add each individual registration object as you're going through it. So for int I equals 0, I less than, I'm just going to call it registrations. So what you're being passed, registrations dot length, I plus plus. And then, so at this point, if you do registrations of I, this is a registration object. And you have already a method that adds registration objects directly. So all you gotta do is call that method, this dot add registration, and you can pass it registrations of I. Everyone good? Okay, so test case 10 tests all 3 registration methods, so it should pass on its own. For test case 11, it's on get marks. So you're getting the marks of a specific course, which is in the registration object. But you're calling this method on the transcript level. So your transcript class has an array of registrations. So what you would do is you'd go through these registrations and you check if the name of the course that you're given matches the name on that registration. And if it does, then you just return the mark of that course. So I'm going to skip over it because I want to have time to do the more complicated methods. But does everyone understand like the idea of it? Yeah? Okay. Okay, so test case 12 also has to do with that method. So I'm going to run it. It passes. Okay, so number 13 is basically the same thing, except instead of get marks, it's set marks. So instead of an accessor, it's a mutator. So this method would be a void, and instead of returning the marks, you modify the mark of the course that's passed. So I'm going to leave that one as well, and I'll just copy over it. Okay, so 14 should also pass because it has to do with the set marks. Okay. So for 15, you have to make get weighted GPA. So the way get weighted GPA works is it goes through all the registration objects and it sums their weighted grade point. So it sums all of them because each, if you remember back here in the registration, you you have get weighted grade point. So what you want to do for get weighted GPA is go through all the registrations, add the weight points, and then you want to divide them by the number of registrations. However, you want to pay attention to this line over here, this assert equals. This number, we call it like the epsilon value. So this is kind of like the margin of error for your answer. And so when you see that, you can think to yourself, okay, this is returning a double. Because for integers, we don't have that. There's no decimal point. So I'm just going to create the method. Okay. So the first thing you want to do is you want to get the total weighted grade points. So I'm just going to write that. And to do that, you need a for loop. So for int I equals 0, I less than this dot number of registrations, and then I plus plus. And you also need somewhere to store all these grade points. So I'm going to call it total weighted grade point, and I'm going to set it to 0. Sorry, declare it. And then I'm going to go through here, total grade point plus equals this dot registrations of I. And then you have the get weighted grade point method. So all you have to do is call it. Yeah. The total weight. You can make it a double, or you can keep it an int. If you choose to keep it an int, you have to keep in mind that your final answer needs to be a double. So here what they're doing is the initial value, like the first value they're dividing is an integer, and then they cast it to be a double. So when you're doing division and you want your answer to be a double, you just have to make sure one of the two is a double. So here I just chose to keep weighted grade point as an integer because the method returns integer, and then I'll add the cast for the double to number of registrations. But you can do it whichever way.
So Judy can give us some quick example.
Yeah, so like if you do like 5 divided by 2, but they're both integers, you would get 2. But if I do 5 divided 2.0, 2.0 is a double value, so you would get the 2.5. So just one of them has to be a double for you to get the decimal in your final answer. So it's up to you which one you want. But also like a good hint, if you didn't really understand how this works, is if you look at the test case, it casts one of these, like this is what we call typecasting. It adds the double cast to one of the last value, what you're dividing by. So you can just follow that format in the test case as well. But yeah, so I'd come here and total, and then I'm gonna add my cast, and then this dot and or. Does that make sense? Yeah.
I didn't make the number of NOR. I didn't make it double, but it still counts.
You didn't cast it, you mean?
Huh?
Like you didn't add this, the double?
Not the double.
Okay.
It should still work.
So there's going to be somewhere in your code that's made double. For example, let's say line 67. Did you declare that accumulated sum to be double? That might be the case, actually.
And is the method double?
The method, yes, it is double, but just return value, right? So maybe we can take a look at your code maybe after the session. So I think the point that Judy was trying to make is when you do division, either the numerator or the denominator, at least one of them should be a double. That's the bottom line. And how exactly you make it happen, there are many possibilities. So
Yeah.
Any knowledge to avoid divided by zero?
In some of the next test case. Oh, sorry, in the instruction.
Let's see.
Yeah, it's about says return 0.
Yeah.
yeah, so currently we don't really have that test case. Yeah, you're quite right. So for example, there's something we didn't really include in the solution. Yeah, so Judy, if you can just go back to the solution you type, right? I think you made a very good point, right, about the logic for division by 0, yes. So in the actual test, it's very possible we don't really give you the case where you might have a division by 0. So that's something you want to think about. So we can do it right away. For
Yeah.
example, we might,
It's a very easy fix. You can just say if this dot NOR is equal to 0, then return 0. And if it's not, then you can just do what we just did in here.
Okay, just to say a little bit more, of course, mathematically, when you actually got this dot NOR equals 0, the weighted GPA is actually 0. Doesn't really make mathematical sense. But for this test here, we actually don't have any exceptions. So the more appropriate way to do it would be to say, if you got this dot NOR equals 0, then you throw some exception. But it's not covered on Friday, so don't worry. But that could be a nice exercise for you guys to think about. Okay. Yeah.
May I ask a question about the get marks?
Sure. Okay.
The first step we want to solve the code is to find the course name in the suggestion. But if do we need to handle with the case that if we can't find the course name in the rejection? Next.
So you want to check the test case for that.
I just want to know if we can't find the course name in the rejection, do we need to write something that specifies?
Yeah, so here, if you look at this test case, it says when attempting to get marks for some non-existent course, so if a course isn't there, simply return -1. So yeah, so just, I know I skipped over it a little, but so what you would do is initialize the mark initially to be -1. Because if the course doesn't exist, then you'll never reach this part inside the for loop, so -1 it'll never be updated. So you'll end up returning -1. We're good? Oh, yep.
We're just wondering, should we add a break after that code?
Break.
Break, yeah, to shorten the processing time.
You could, or I don't know. I don't think you're allowed to use breaks.
Break, you're allowed to use
Okay.
it during the test. However, again, it's all about, like a good practice. So you can feel free to Google. So there is like a bad practice calling creating spaghetti code. Spaghetti like a food. So if you actually got lots of break and continuous statements in your code, then in a large scale software, you can have very complicated control flow, which you don't really want to get into. So I would say, for the kind of complexity for our code to be written in this course, you can easily get away from them. So don't write a break or continue. It's good practice.
But also, like,
It's a Boolean.
you could use a Boolean as well to over here. You could have a Boolean called found, and then when found is true, then you exit. But during a test, when you have that time pressure and that time crunch, you don't really want to be worrying about these things because the end result is the same. Yes, your code may be faster, but that's not what we're testing you on. So
Yeah, in the test, the bottom line, whenever you write a loop, just make sure it terminates. Right, that's the bottom line. Yeah.
yeah. Okay. So this next test case is a long one. So the method that you need to create here is delete registration. So Delete is one of those trickier methods that might not be entirely intuitive to you. So what I like to do is start by tracing the method. Okay, so you want to think of delete as shifting whatever's after the index that you're trying to delete this way. So you're trying to kind of replace what it is you're deleting by everything that comes after. So you're shifting this way. Okay, so if I have an array with registrations here, and I'll just do one more. Okay, so this is index 0, 1, 2, let me erase that, and 3. Okay, so let's say I want to delete what's at index 1. So I want to get rid of this element. What I would do is, again, think of shifting this way. So instead of index, like this reference pointing to this object, I would have it point to the next. And then same thing, you'd keep going. I would have index 2 point to the next object. But what you'll notice is now index 2 and index 3 are pointing to the same object. So you want to make sure that you remove this reference as well when you're doing it to get rid of the duplicate in the array. So what you can see is before you do delete, what was at index 1 is now at index 2. And what was at index 2 is now at index 3. So you can kind of see there's a pattern. So what you get is what was at index I is now index I plus 1. Okay? So if I switch back to my code, create the method, and then I'll write for. So you're past the index of the element that you want to delete. So for int I equals, you want to start at the index because that's the element you're getting rid of. Just regular I less than number of registrations, I plus plus. And then just like Okay, just like we saw here, what was at I is now at I plus 1. So we're going to come back here. So this dot registrations of I is now this dot registrations of I plus 1. Okay? But then you want to handle that duplicate at the end, so you want to get the last element. So this dot registrations, last element would be this dot NOR minus 1. And you want to set it to null. And then you want to adjust the counter. So this dot NOR minus. Okay. Does that make sense? Yeah? Okay. Yes. Sorry. Yep.
So let's say when the array will be the full, like there's a maximum number of registrations, right? I think 60 or maybe 60, right? So let's say when the array is full, isn't that I plus 1 will cause error when we are iterating through, because we are having I is less than this dot number of registrations. So if I is less than this dot number of registrations, so we can say I will be maximum of 59. So when we say 59 plus 1, that will be error.
Let's say you want let's say the array is of index 60 and you want
Mhm.
to the array is of length 60
Mm-hmm.
and they're all full, all those slots are full.
Mm-hmm.
Now you want to delete the 60th element in that array. would that still work?
So your index would be 60,
Yeah.
okay? 60, number of registrations would also be 60. So 60 less than 60 is not true. So you'd never enter this. So what you would get is then you would just delete the last one.
No, I mean
So-
to say 59. Like when we say 59 plus 1, so it will be 60th index. But actually we have the length as a 60, but the index will only go till 59, right?
Yes. So
So when we call I plus 1 and index value is 59,
Yeah.
so 59
Oh,
plus
I
1
see.
60
Yeah.
will be
Yeah.
I do see what you mean. So there's a boundary case you're talking about over here. Yes. I think for the purpose of this practice test, we would say we might just assume that we don't really delete from an array. That actually is already full. We can make that assumption. In the actual test, we're trying to make that assumption maybe explicit. Otherwise, you're quite right that you may have to modify the code slightly just to make sure, if you actually just try to delete from a full array, then you're right, I plus 1 may cost you index out of bound exception. Yes. So what Judy can do, for example, is what we can do just for here. She can just say we assume that the array to delete from is not full, right? So for the very last iteration, we wouldn't run into that kind of exception. Okay. It's very good insight you guys are thinking about.
yes.
I'm not sure if this is the same question that you asked, but then why not do before why not do this does no and minus 1?
Here?
Yes. Why not add a minus 1 there?
Oh, I mean, and line number 85?
No, it's 2. He said
Here, he's saying, why don't you do this, right?
it's not one short.
Yeah.
Because it would be shifting one less. Yeah, you're supposed to shift everything to the right by one position.
No, I'm not saying like that. This guy did the same thing, but I put minus 1 there and it still run.
Yeah, it could be there might be some additional test cases that can catch that. But I think this actually will be better. Yeah.
Yep.
I've done some sort of thing that's very similar to lab 1 by instead of using like a sorting algorithm, I created some sort of extra variable. Would I still get full marks if I did it that way, or would it be necessary to do it basically just using one?
Did you say you do some sorting?
Basically, like I basically took an array and I took one element within that array, and then I took the next array and I swapped it, and I took.
We can take a look at maybe your special solution. I would say as long as you're only using primitive array and for loops, and somehow you can still make the solution work, you would definitely get the marks. Because we're going to grade your submission, just by if you can pass the test cases. If you can still pass the test cases by your solution, it's definitely fine. Yeah. So just before Judy continue, I would suggest we pause the recording just for now, and then. All right, we'll continue.
Okay, so I don't think we actually ran this test case, so I'm gonna run it. Okay. So that's delete. So 17 should also, actually, hold on. Okay, so 17 is the start of a new class again. So it's the same error that we saw previously. So it just means you need to create the registrar class. So I'm gonna click create class. Again, we want it in the model. You click finish. Okay, and then I'm gonna come back here. So get all transcripts is very similar to get report. So I'm gonna leave that one for you guys. So I'm just gonna copy it over. Okay. So 18 also is an add method. So again, it's the same like pattern that you guys have done. You know how to do this. So I'm just going to copy it over as well. Okay, so 19 is where things get a little trickier. So this is definitely a test case that you would want to trace. So there's two methods in here. The first one is set registrar office. So you want to link the transcript object to the registrar. So I'm gonna, switch over to here. So what this method is doing, it's very simple. So you have a registrar object. Hopefully everyone can read that.
Well, better than my writing.
So each registrar object has an array of transcripts. So I'll do them in blue. Okay. A little crooked, but that's fine. Okay, so the transcript object has an attribute of registrar type. So here, I'm just going to call it registrar. And then it would link back to the registrar that it's connected to. So you kind of have them go in both directions. So does that make sense? Yeah? Great. So it's very simple to code, actually. So you just want to go back to your transcript class and make it an attribute. So private registrar. Control save. And then, so here, this is on the transcript level. So set registrar is in the class transcript. And it's a void, obviously, because you're setting an attribute, you're not returning anything. And just write this dot registrar is equal to the registrar that's passed, so R, control save, and then that's it. The trickier part is get students. So get students returns a string array of students' names. So students' names are in the transcript objects. So who are enrolled in a specific course. So you're passed the name of a course, which was in the registrations, but you're returning an array of students' names, which is on transcript. So this is definitely one you're gonna wanna trace. Over here.
I'll just mention one thing. Judy can just switch back. Yeah. So when you actually study for this particular test, you can look at line number 354 specifically. You can see the method call we are making now is a.setStudents. So where should we put this getStudents method? Right? So you want to look at the context object, which is A. Its type is actually transcript. Right? You can see in line number 326. So that's why you should really put the getStudents method in the transcript class. That's what Judy is going to explain to you, how exactly things will work together. But just don't forget, in the test, you always want to look at the context objects. Okay.
Okay, so what you're doing in this method is you want to go through all the transcripts that there are in a registrar's office. So you want to go through all the transcripts to be able to go through all the registrations. And then once you have all the registrations, you want to check if their name matches the name that's passed to you. And then once you confirm that that's the course, you want to go back and get the names of the students, which are on the transcript. So it's a little confusing, but it's much clearer when you draw it. So, okay, I'll do my registrar in green. And then so each registrar office has an array of transcripts, and you have a method in registrar that returns this array, which is get all transcripts. So you have your transcript object. And then each transcript object has an array of registrations. So I'll do them in purple.
Oh.
I'll just say.
It's not reflecting. Okay.
Oh.
Yeah. One moment. I'll fix it. Yeah. Let's do it the proper way. All right.
Okay, so you have your registrar object, and then each registrar has an array of transcript objects. And then those transcript objects have an array of registration objects. And the registration objects is where you'll find the name of the course, which is what you're trying to compare. So the challenge is then, how do you get to this name attribute? So you're doing two things here. You're going through all the transcripts, and then for each transcript, you're checking all its registrations. So you can kind of already see you're going to need a double loop. Yeah?
The name is actually stored in the transcript.
So the name of the student is stored in the transcript. Yeah. But the course name is in the registration. Yeah.
So when I was making the student name method, I also got confused whether to put like in register or transcript. But I put it in transcript because we have the method that we declared as student name, and then it passed. Is that still right?
Yeah, so hold on. Okay, so I'll just write it down. So the transcript has the student's name on it. So, is that legible? I hope. Okay. And then the registration has the course name. Make sense? Does that answer your question?
Like the previous test case you did, we were creating the method student name. I think, yes, student name, but you put it in the registrar's class. That's why I got a little bit confused. Why don't we put it in the transcript class? Because we've already created an attribute called student name.
Sorry. Get student name, you mean?
Yeah.
Did-
Is this the previous test case?
Mm-hmm.
I think you made the method in the registrar class.
No, we haven't made it yet.
Sorry.
Yeah, not yet. It's okay. Yeah.
I know it gets confusing. But yeah, okay. So what you do, yeah, so you can kind of tell you're going to need 2 for loops. So you're going to need one to go through each transcript, and then you're going to need one to go through each registration of that transcript. So if I want to get the course name, what that might look like is, well, firstly, you want to get all the transcripts, right? So you want to go to the registrar and call get all transcripts. And that will give you all of this. Okay? And then you want to look at each. I clicked something, sorry. So you want to look at each transcript object. And so I'm going to give the transcript object I'm looking at a reference just so it's neater. So I'm going to call it T. Okay, so then once you do that, you want to do T dot. You want to open, or you want to get all of these registrations, and you have a method that does that, which is get report. So get report, but get report returns an array. So you want to give it like an index to access the individual registration name. So I'm just going to call it R. But for now, let's just say this index is J. And then once you have that, then all of this becomes then your object R. And then you can do dot get course name. Does that make sense? Yeah? Okay. So if I go back here, so get students is on the transcript level. So get students. Okay, and you're past the course name. Right, course name. Okay, so the first thing you want to do is you want to get all the transcripts. And how do you do that? You got to go through the registrar. So transcript array, I'm just going to call it transcripts, is the this dot registrar dot get all transcripts. Okay, and then you want to create a string array. I'm just going to call it temp for now. So when you're initializing the array, you have to pass a size, right? So you would write new string array. But you might be wondering, what do I make the size? So in this case, you want to look at the worst case scenario. So what's the maximum number of students I can have? So that corresponds to the maximum number of transcripts you have. In other words, it's transcripts dot length. Okay. So you can also see, if you go back to the test cases, the result is actually returned in an array that's of length 1, or if you look at the later test cases, you can see it's length 3. So your final answer needs to be returned in an array of like corresponding length to the amount of objects you find. Yeah.
I wouldn't say that's the worst case. I think the worst case would be like 100 times 60. You could have a student have the same course 60 times. Oh, well then the name's the same on that one. So
I don't think you can add the same course to a student's transcripts more than once.
in this small example doesn't have any error handling for that.
Mm-hmm.
It's not part of the program.
Yeah, it's kind of beyond the scope of this particular task. We're just assuming that's something simple. Yeah, for now.
But I mean,
Like what's stopping you from counting the exact number of students that have that course?
nothing. You can have a really super duper long array because, I mean, by the end of it, you're only returning an array of like size of the amount of objects you find. So your initial array can be however big you want it to be. You just don't want to put yourself in a position where you have more students than like allocated spaces in your array.
Like my strategy was to basically go in as deep as like double in and then count up the number of students that actually have the course names and then after the fact initialize the array that I intend to return. Because I'll know the exact size. And I basically copy paste the exact same for loop structure and then just add the name.
Yeah, so you basically did the same thing twice.
Yes.
Yeah.
pretty much so. But that's kind of the motivation for array lists, but we're not there yet.
Yeah, of course, in the test, you wouldn't be allowed to use array list, but of course, I think the way we're doing things over here is very similar to how we did it in point and point collector example. If you remember, there's a method there called getTrojan1 point, something like that. So you guys may want to review that method before Friday. I think that'll be very beneficial as well. So I think what you said is definitely valid. You can, first of all, count about exactly how many students should be collected and then create the array accordingly. That's definitely one way. What we're doing is we create long enough array, and then we try to assign a student into the array, first of all, and see how many exactly we have, and then we copy over to the actual array to be returned. So I would say both solutions there are really equally valid, I would say. Yeah, just choose the one you like.
Okay, so then you need a counter for this array, like you do for any other array that you make. So then you can actually get into the for loop. So for int I, and this for loop will be for going through the transcript objects. So less than transcripts, or you can just call, yeah, I'll do transcripts dot length I plus plus. Okay, so now you're looking at transcript objects. So I'm going to make a reference to that object. I'm going to call it T, just so it's clear which one or like what you're looking at. So transcripts, sorry. Okay, so now that you have your transcript object that you're looking at, you want to go through its registrations. So you want another for loop. So I'm going to use j less than t dot get report will give you an array of all its registrations dot length. And then j plus plus. Okay. So far so good? Okay. And so now you're looking at an individual registration object. So I'm going to call it R. This will be t dot get report of j. Okay. So now that you have the registration object, you can compare the course names. So if r dot get name, get course name dot equals, because it's strings that you're comparing, course name. So that means the student is taking that course, so you want to add the student's name into the array. So you call temp and write count equals t, which is the student you're looking at, dot get student name, and then increment count. We're good? Yeah.
Could you explain the purpose of the temp array?
Yeah. So initially, you're just going through and adding, but you don't know how many students are going to end up being in your final answer. So you need an array that's large enough to take in the students first, and then you're going to go back and adjust the size, because in the test case, you have to return an array of appropriate length. So the length has to correspond to the number of students you actually found.
Yeah. For example, let's say in total you got 100 students in the system, but it turns out for the course you're looking for, you only got 50 students, in which case you only filled out the first 50 slots. But you cannot just return the array of size 100. You have to make sure you only copy the 50 slots over and then return it.
Okay.
Yeah.
Any other questions? Good? No? Okay. So now you can go ahead and make your final string array. I'm going to call it result. And so now I know how many students I have, so I'm going to use count, and then just a for loop to copy over the results into my new array. And then you want to return temp. Whoops. Oh.
You want to return it?
Oh, yes, result. Whoopsies.
Yeah, watch out what you're returning, right? You did all the hard work, but maybe just the final line. That's not returning exactly right. But the test case will actually tell you actually failed. So you can take a look using breakpoint and debugger to find out what's wrong.
Okay.
Question? Go ahead.
Yeah. Sorry, what? Yeah, sure. That's a great idea, actually. Okay. So I'll place my breakpoint here. I'll switch to debug mode. And then I'll launch, oh, I closed them. Launch the debugger. Are you guys seeing anything?
Maybe you want to double click on the debug tab again. So it will come back. Here we go.
Okay. Yeah, so you want to step into. Okay. I want to open the variables. So
Window, show view, and variables.
I'll move that over here. Okay. Can you guys see that? It's very small, right?
Yeah, I mean, you can just read it out. Yeah, but
Okay.
if you actually follow the step, you will see very clearly. Now, just a little bit like a projected resolution, so we cannot really do anything with it. But Judy will just read out the variable value.
Okay, so I'm gonna step over this. I just created my transcripts. I got all my transcripts. I have 2. Okay. And then I'm gonna create my temp. Temp here. I also have 2. So temp has size 2 because I have 2 transcripts. And then count 0. And then for loop. T. So T is the first transcript. So number of registrations is 1. And the student's name is Alice. And then I'm gonna step over. Okay, so now you're in the second for loop. I'm gonna get my registration object, which is R, and the course name is math. Okay? Does that help? Yeah? Okay, and then I'm gonna keep going. So the course name was not math. So you didn't enter this part of the if. Yeah. So you keep going. You're going through the rest of Alice's, the rest of her registrations.
Mm-hmm.
Yeah.
Yes, one thing we can also do, maybe I mentioned that in the tutorial video. So Judy, can you just put a breakpoint maybe in line number 113 outside the for loop? Let's say somehow you don't really want to go through the details about the double nested loop, right? You want to go directly after the loop. What you can do at this point, I want to jump from 104 to 113. Rather than saying step over, you can say step return. There we go. So now we are in 113 right away. So now we can kind of look at what's the count and what's the temp array, right? That kind of shows to you. Yeah, somehow you kind of just execute the whole double nested loop at one go without you having to step over. That kind of gives you flexibility. If you actually only want to look at what the double nested loop really calculates, you can just say put a breakpoint right after the for loop and then say step return. That's one thing you can do, right? Yeah.
Yeah.
Just to follow up on that. So like sometimes I was putting like break statements once I found what I wanted.
Yeah.
So instead I could do this.
Yes, you can do that. So basically, let's say between the two breakpoints, sometimes between the two breakpoints, you may actually have many things in between. If you don't really want to look at them each one by one, you can just say step return. So that will jump from one breakpoint to the other. Yeah.
But I think if you're a little confused on the double loop, one thing you want to keep in mind is like the inner loop, the for in j equals 0, that one you execute that entire loop before you go back to I, so before I is incremented. So you start in the outer loop, the inner loop is fully executed, and then the outer loop starts again. Does that make sense? Yeah? Okay. Okay. Okay, so the next 3 test cases are on this getStudents method. So I encourage you guys to redo this method on your own because it's a lot. And then you can trace the test cases through the next ones. Yeah.
I guess just one question about the test case you just did.
Uh-huh.
Like in the JUnit test case, line 357, it says A dot get student and then coding, like it passes the term
3.
357.
Maybe it's not the same line. I thought
Yeah.
which test case are you
This one?
talking about?
The test case will be test 19.
Yeah, so this is this line?
Yeah, A dot get students and then it passes coding. So I want to look up to see like what is A, like what would the string coding be. But when I go up, A has to do with transcript, and then over there it says B dot and then passes coding. Like what I'm like confused about is how come the test case doesn't say B dot get students and then because it's passing string coding. But if you go up, A is like corresponding to hours.
Okay, so that's a good question. So here, A is its transcript object, and B is also a transcript object. But you can see, sorry, that's very bad square, but they both are under the same registrar, right? So when you're doing your get all transcripts, you're actually returning this whole array, this entire thing. So whether it's A here or B here, sorry, B, they're both being added to the get transcripts of the registrar. So that's why they're both being looked at, even if like A didn't add that registration or that course. Does that answer your question? Yeah. Okay.
So here the critical thing is, given the transcript, you want to go back to the registrar it's linked to, so you can get a whole array.
Yeah.
So for these double loops, right?
Mhm.
Like in this particular scenario, we are trying to get the coordinates, right? On the last
Mhm.
array, right? So what I don't understand is the conditions for the loops, for the two loops. Is it always that the condition for the inner loop, for the inner for loop, the length, like I is less than the length of that array, or
Okay. So the
and the
Yeah.
outside one the condition becomes I is less than the length of the top array?
okay. So to get to the registrations,
Yeah.
you have to go through the transcripts, right? So that's what the outer loop is doing, is it's going through all these transcripts. So the condition for the outer loop is it's I less than the transcript's length. Because you're going through like this entire array.
Mm-hmm.
Does that make sense? Yeah. The inner for loop is you're going through the entire array of registrations of that one transcript object. Yeah, so the condition for that loop is I less than t, so this transcript objects dot get report. So get report is the array with all the registrations dot length, so the number of registrations. So again, so it's t, this transcript dot get report would give you this, and then dot length. So you can go through each registration object.
So let's say, for example, let's say for that particular transcript, maybe its internal array is of size 100. But when you actually say get report, it's going to give you the corresponding length about how many registrations that have been added so far. So that's why it's precise. So that's why I can say get report, which will give you exactly the corresponding number in the corresponding object that's already stored in the array, and then that length. That's going to give you the right length. Right? And similarly, when, for the get transcript as well, yeah, for the outer loop. Yeah. So when you actually write the boundary condition for the loops, got to be very careful about you only go over only up to where you are, like where's the last added object in the array. You don't really want to go over the null slots, in which case you might get null pointer exception. Okay? That's also something we cover in the lab. Yeah.
Are we good to move on? Yeah? Okay. Okay, so this last test case has to do with static variables and static methods. So the first thing you want to do is I'm just going to get rid of all the compilation errors. So you can see there's generated a static void method. Another way you can tell that it's a static method is it's directly called by the transcript class. There's no instance object calling this method, it's just the class. And then you have getID, which returns a string. So it's also in the transcript class, returns a string. Okay, so for reset ID counter, that kind of gives you a hint that you have a static variable called ID counter. So I'm going to go in here and write private static int ID counter. So this ID counter is incremented whenever a new object is created. So it's like a global counter for all the instance objects to access. So what that does is, sorry. Okay, so you have the global counter, and then you also want to make the instance object's own private ID attribute, right? So private int ID. Okay. So another thing you want to do is you want to come back to the test case and look at the pattern of the IDs. So here they're just being incremented by 1. So what you want to do is come back to transcript, and in the constructor, you want to do this dot ID, which is the private instance variables attribute, equals ID counter. Sorry. And then you want to increment the ID counter for the next object. Oh, I didn't reset the counter actually. No, okay. And I didn't initialize the counter either. Okay, so ID counter, since the pattern starts at 1, you just initialize it to be 1. Okay. And then, so here, reset counter, since we initialized it to be 1, you want to go back to ID counter being 1. And then string.getID is, you want it to return a string. So an easy way to do this is to just copy one of the assert equals. So you have the string format, and then come in the return, write string.format, sorry, paste. Okay, so Alice is the name of the transcript, the student name. So %s because it's a string, and this dot student name. ID is 1. So 1 is her ID, so it's an integer that you're replacing. So %d, and you want to do this dot ID. And then we're done.
All right. Any questions?
Yeah.
So I have to know how to do the string format for the test.
You could concatenate, like with the plus signs where you have like a string and then you do plus and then another string. That works too, but it's really time consuming. So I would say, yeah, it's better to use string.format.
Yeah, I would say, of course, in the actual test, if you really forgot certain syntax for the format, doing concatenation is also going to work as well. Okay.
Yep.
Could you go to the register until pixels one of the things?
I think the solution will be available to you.
Yeah.
Yeah. Yeah.
What is like for the attributes for ID counter? What happens if you don't put static there?
So static is the global like counter. So it keeps track of how many instances of transcript you have. So if it's not static, then the individual like instance objects you can't see how many there are. Does that make sense?
Yeah, for that one, you may also want to look at the slides for the static variable. We do have some common error. I think one of them actually corresponds to what you just asked.
Yeah.
I have a question on the delete.
Okay, how about we take the any questions? We'll stop here. Thank you so much for coming, and then we'll take any question maybe at the front. Okay. Thank you. Yeah, Judy, I'll let you handle.